are a lot of places where one size fits all works just fine. Unfortunately, one of the places in the one size fits all world that doesn't quite work for me is hats. Yep, one size fits all hats are generally pretty useless for me. Maybe it's because I've got such a big brain. Well, another place where one size fits all doesn't quite work is with Wi Fi 6 and 6E. With Wi Fi 6 and 6E, you have a variety of features, unlike previous versions of Wi Fi, that have direct implications on your end application. So if you're going the Wi-Fi 6 or 6E route for your next high throughput, high density, battery powered design, and you need to keep your power budget low, you should consider the Sona Wi-Fi 6 and 6E solutions from Ezurio. Let's get into it. Hi, I'm Amelia Dalton, host of Chalk Talk. In this episode of Chalk Talk, Andy Ross from Ezurio and I explore why a one-size-fits-all approach doesn't work for Wi-Fi 6 and 6E, the specific benefits of the IF573 and IF513 series of Wi-Fi 6E modules, and how to choose the right radio for your next design. And before we get started, don't forget to click that link. There you can find even more information about this topic from Ezurio. Hi, Andy. Thank you so much for joining me.
I appreciate you inviting me.
Absolutely. Okay, so we're talking about how we can optimize our designs with Sona Wi-Fi 6 and 6E. When it comes to Wi-Fi 6 and 6E, one size fits all solution doesn't work, right?
Right, and it's the first time this has really happened on any scale with the Wi-Fi technology, so it's actually a critical turning point. So yes, it's definitely not a one-size-fits-all. Wi-Fi 6 is the first time with Wi-Fi that it hasn't been focused purely on one particular feature, either security updates or throughput updates. There really was a set of very important features added to Wi-Fi 6 that are very broad in terms of implications, not only in terms of the features that are inside Wi-Fi, but also in terms of how they apply out into the application space. You know, we have things like OFDMA, TWT, BS coloring, MIMO, and then some of the more esoteric dual carrier modulation and long guard interval adds that individually have their own benefit. But when you start tying one or two or three of them together, kind of arrive as a much larger benefit that can be directly mapped to, for instance, an application. So by combining OFDMA, multi-user MIMO, and the QAM 1024, you can start talking about getting higher throughput out of Wi-Fi 6. When you start looking at OFDMA and then the long guard interval, you can start talking about getting improved range. And then the other ones kind of map together to give you lower power, better latency, and even access to a more efficient infrastructure. And those sound kind of nebulous in a way, because ultimately it's how does it work in the application? And so as you take those kind of combined benefits and look down into the application space, you start talking about high bandwidth, you start talking about high density applications, you start talking about low power applications, you start talking about industrial automation and AI type applications. And again, there's a further combination of those performance benefits and outcomes that go to apply to a particular application. So, you know, a high performance medical bandwidth or a low power sensor type application. And it's not a one size fit all. It's really, you can pick the things out of the set of benefits that Wi-Fi 6 brings to specifically address the challenges that your application actually has.
That makes sense. Now, Andy, give me some insight into the Sona family. What are the prime benefits of each of the different solutions in this family?
I took a very specific approach on the Sona family, acknowledging that it wasn't a one size fits all. We couldn't just create one or two radios and feel comfortable that we had application base covered. We looked out and said, no, there is a group of products that are needed in order to provide a solution for everybody and an optimized solution. So you're not having to compromise. If your application says, I need low power, I need throughput, or I need range, you can really pick a product that's been designed to get the best out of Wi-Fi 6 in that particular application space. And so we have actually 5 different radios inside the Sona family that range from a high-performance 2x2 PCIe SDIO radio capable of hundreds of megabits throughput, through to a low power, that's both operating and standby product. That's a tri-band solution. We have a product that's a very, let's say, cost-efficient product as well, because that becomes one of the features that are interested in Wi-Fi 6. And we've put together a group where there's a little bit of overlap between them, but really there's a specific reason why they exist inside the family, kind of going back to that discussion around the application breakdowns, making sure that there is coverage for each of those breakdowns in one or maybe 2 of the products inside the family. And we have one family that's called Sona, which is a transceiver-based family, and I'll talk about that a little bit later probably. But we've also complemented that product range with a new range of products called the Veda family, which fall under a class of product that is starting to be known as a connected MCU. And we can talk about some more detail around that. But the connected MCU is an acknowledgement that the processing performance of MCUs these days is at a level where it's starting to encroach upon the lower to lower mid-level applications that the more traditional CPU A-core ARM sort of products are. And now the M-cores are able to actually deliver performance that allows them to be considered for something other than like a home automation or a consumer style product, that it's actually at a class that can apply to an industrial or medical space. So we've got this coverage that is unique in the market in terms of the total coverage inside the industrial medical type space. And we continue to add to it, and we continue to expand upon it in terms of the software support underneath. And even where there are little holes, looking at backing those up with additional family members as the technology becomes available.
So, can we talk a bit more about the Sona IF573 Wi-Fi 6E solution? What specific benefits does this solution bring to the table?
This is the showcase part. This is the top of the range. This is the performance device. It's a 2x2 radio, gets you higher throughput, better link performance. It has a PCIe host interface. It also supports SDIO as well, but at the PCI level, you're able to start talking about hundreds of megabits throughput on this, which there are obviously a bunch of applications, and we'll talk about some of those in a minute, where being able to push a lot of data quickly is absolutely critical to the application. It also has a separate Bluetooth connection, meaning that we decided not to compromise Bluetooth and or Wi-Fi performance by forcing them to share a particular antenna port. We have separate Wi-Fi and separate Bluetooth connections so that they can work without stepping on top of each other and maybe compromising overall performance. So the focus on this product has very much been making sure you can get the most you can out of the product, out of the technology, when stuff like throughput and latency are critical to you.
What kind of applications would this solution be a good fit for?
It's actually a very broad range, and I think, as we say, there's, one size doesn't fit all. There is no one size application. Each application has its own demands, has its own requirements. And the sort of ones that we've run into that have historically and continuing to show need throughput in the industrial and medical space, for instance, the hospitals and the robotics, information is not being decreased. It's exponentially increasing every time something new comes out. And the ability to access, deliver, and then respond to that information is again multiplying as the data size goes with it. And this is true as a model in both the industrial space and the medical space. So we see, for instance, in the robotics and automation space, there's an increased level of vision that's being used. And so there's higher levels of data just because there's more information be created around the vision stuff, especially when linked to AI. There's also increased actuation. There's a need for lower level of latency, i.e. the delivery of data backwards and forwards between, let's say, a data source or analysis point on a network and the actual actuator itself. And this is true in industrial space. This is true in hospitals where access to the medical data is no longer acceptable to wait for a day or two. The expectation is that the data is needed very, very quickly. And when we're talking about things like MRI scans or X-rays, it used to be you're going to have to wait a few hours or maybe a day to get your results. Now the expectation is that diagnosis and treatment is being started almost instantly based upon the data being available almost real time as it's being recorded inside the equipment at the hospital. And so all of these things have lots of data and they need it as quickly as possible. And so high performance, i.e. a 2x2 with 80 megahertz channel capable of getting technically 1.2 gigabits across it, but in practical terms, 600 to 800 megabits across it, means that these sorts of applications are handled very well with, for instance, the 573 product.
Andy, what about the IF513 product? What are we looking at for benefits with this solution?
So, here's 513. It's based upon an Infineon chipset. The 573 is based on an Infineon chipset. And here's a demonstration of where the silicon developers themselves have acknowledged that they need different technical solutions to address the different demands of the applications, acknowledging that the one size fits all for Wi-Fi 6 truly exists at the silicon level. And so the 513 is a really interesting part. It's low power, currently the lowest transceiver power part that we have. Its focus is around being able to handle battery-powered applications. And as a result, there's a little bit of a compromise. And a little bit of the compromise is that it doesn't do the super high performance. So it's a 1x1 radio. It's limited to a 20 megahertz channel. That still gets you tens up to 100 megabits of throughput, which, compared to almost a gigabit doesn't sound a lot, but for a majority of the applications is enough to get you what you need. And so it has a really nice sweet spot in terms of where it fits in the market. It's a very competent, capable part, but is focused on being able to deliver the power advantages that Wi-Fi 6 brings in, and then also tying that with a very performant Bluetooth solution in there as well. So this is very much not fast and furious, but really quiet and reliable and being able to do it on a very low power budget.
So, Andy, what kind of markets and applications would this solution be a good fit for?
It flows out of that power focus. So wherever you imagine that power will be an issue, this is where it floats in. That is battery powered. It's the most limiting thing in terms of an overall application guideline. And the good news is for this particular part is there is an increasing demand for battery powered equipment, mainly around the fact that people want this equipment to be mobile. They don't want to have to mount it to a wall or attach it to something and have to have lots of them around. They would much rather have a piece of equipment that could be carried with the person that needs it so that you can get the best efficiency in terms of use of it. And, that sits with things like doing test and measurement, even warehouse automation where you have autonomous vehicles, even human-powered vehicles, like forklifts and robots running around. And then the kind of obligatory sensors that are required inside these environments now, because there is so much automatic equipment in there, the ability to sense and then actuate is obviously critical to the overall application. Often those devices are battery powered. In almost all cases they are. And they have a minimum operating period. So, they have to run for 8 hours or 12 hours or 24 hours. And so the ability to save data means that the end product is able to meet that critical requirement in the target applications. Other demand that's coming into these products is also to reduce the overall size of them. It's now expected that it's not a backpack, it's not even belt worn in some cases. It has to be hand carried or it's mounted on an arm or something. And this means that the overall size needs to shrink. And one of the biggest components in terms of overall size is the battery. If you're able to develop and deliver a product that uses less power per piece of information delivered, that means you can consider the use of a lower capacity powered battery and therefore actually a smaller battery as a result. So in this particular case, the ability to offer a low power operating and standby product means that the customers who are going to use it are able to then consider providing a benefit to their customers with smaller form factor products.
So, Andy, when choosing a radio, what kind of design considerations should we keep in mind?
I say whenever I talk about this, and even to our own salespeople, is that don't start with the radio, start with the application. You be critical about what's important in your application. Is it throughput performance? Is it the latency of the data, the power consumption? Is it the range? Do you have a particular device density constraint, or do you have a target infrastructure that you need to go to? And if you can pick maybe as few as 2 or 3 critical application needs, and we're not talking about needing to know 10 milliamps or 14 megabit throughput, just knowing that it's at a certain level, maybe over 100 megabits or under 50 megabits, that I need to have a battery that's going to run for 8 hours, and I want the target size to be something like a 5,000 milliamp hour or something like that, allows you to then create a fairly coarse but extremely useful characterization of your application. And then if you go back to the kind of earlier description that I showed, for instance, in our product line on the Sonas, where each of the products have a particular benefit, you can then match your application needs to a particular radio, which means instead of having to wade through 6 or 7 or 8 or 10 radios, you can narrow down your focus to the ones that you know match your application demands and get to the point where you're able to spend more time on stuff that's useful as opposed to just spinning wheels, trying to kind of filter out the stuff that doesn't make sense.
Absolutely. Okay, so Andy, let's step back a little bit. What exactly are connected MCUs, and how do transceivers and connected MCUs compare?
This is a relatively new one for us. It's relatively new in the industry. We're not the first guys to do it. And in fact, connected MCUs from Bluetooth vendors have been around for a long time. If we look at our Sona line, we call them transceiver radios. These are radios where you have Wi-Fi and Bluetooth radios. They support the level 1 and level 2 connectivity, but the ownership of the network connectivity and the application side of stuff resides on a host platform, a platform that they need to be connected to. So the radio itself is relatively dumb until it gets connected to a platform. The platform has the intelligence, has the software in order to bring that radio up and get it in a state where it becomes a useful pipe for sending information backwards and forwards. This is a very traditional architecture and was the architecture that was at the beginning of the introduction of Wi-Fi. Our new product line called the Veda or connected MCU pulls into the actual device itself a compute platform and memory so that it no longer relies upon a host to function. In fact, the single device, a single piece of silicon, is able to operate as a complete platform, allowing all of your necessary stacks and applications to run inside the device. The only then requirement is to provide inputs and outputs to it so that it can interact with the world. This has only been enabled recently because of the performance of the M-class products reaching up into that kind of lower CPU product. And vendors like Silicon Labs, and specifically in our Veda line, we have product from Infineon as well. But recognizing that this as a solution applies to markets that traditionally they may not have thought about. So this is where enterprise software is required. This is where enterprise level security is required. This is where internet connectivity is all part of the solution that needs to be provided. And they've enabled it not only through the silicon, but with a whole bunch of support software and development system stuff on the back end.
So, Andy, what kind of options do we have with the Veda family of connected MCUs?
So our family is a relatively small, it's a new one. We just introduced it last year. We have products from Silicon Labs, a single band M.4 based product. We're introducing a much higher performance both dual band and tri-band solution based on Infineon technologies that we're calling the Veda IF912 and IF913. These are M33 class processors. They support a range of memory, have a whole bunch of I/O, and in very small packages. The great news is they all fall under our connected certified product families. So we provide pre-certification for a number of countries on all of these. We provide tested and approved antennas for use and have a support network behind to be able to assist in doing development and deployment of these products out into the market. When we talk about applications, I mentioned that these were the lower to lower mid applications that traditionally might have been delivered by a discrete CPU solution, like a transceiver radio with a processor and memory and I/O. But now these applications are open and available, and in fact, start to look very appealing to the OEM developers because of the benefits that a connected MCU brings in. And so we've run into things like industrial vehicle gateways, portable medical stuff, and also sensor hubs. And the reason these exist is, one, the actual products themselves are small. In the case of the IF912, we have a SIP that's 7 millimeters by 11, which even when you add in an antenna and peripheral circuitry, gets you inside kind of a 12 by 14 total radio footprint. It can even be smaller if you don't want to use a chip antenna but want to use a connector. They are very power efficient. You've got a single piece of silicon doing all of this work. It means that power management is much easier and as a result, much more efficient. And so you get a very power efficient application. And as I was mentioning earlier on with the 513, the challenges or the path that's being taken with these mobile applications is that, yeah, great, love them being mobile, but we really want them to be smaller. And so this goes on to further enable the goal of being able to get more power efficient, therefore smaller batteries, therefore smaller footprints, without having to compromise performance. And so the 912 and 913s give you dual band and Wi-Fi 6 tri-band connectivity on Wi-Fi, gives you Bluetooth 5 capability, plus a whole subsystem of MCU and memory with I/O support. It's a really compelling solution and one that we're expanding. We've got the two product families, the 912 and the 913 and the Silicon Labs 917. This will be expanded in the future for sure. It's definitely an emerging solution for the industrial and medical market.
So, Andy, if my audience wants to get started using one of these solutions in their next design, what should they do to get the ball rolling?
You look at your application. This isn't the same old, same old. You can't just go out and find a radio. Look at your application. Be critical. Be honest about what is important. Is it throughput? Is it latency? Is it power? What are your integration needs? What are your functionality? Go do that work. It usually doesn't take too long because customers know what they want to do. They know they need a product to do certain things. And so, but this is just okay, let's step back and define it and then step into the world of radios, knowing that what you need is a throughput radio, or it's a low power radio, or it's a dual band, or it's a tri-band radio based on new things. Because then that will make their next step, which is then picking one or two or three radios, and then the evaluation of the radios, much more applicable than it would be just to go out and try and grab everything. And well, we'd encourage you to talk to Mouser. They have all of our radios. You have all of our DVKs. You've got a great support staff, and we do what we can to make sure that you are supported, either directly or indirectly with our partner Mouser to make sure that the customer gets what he needs.
Fantastic. Well, Andy, I think that's all I have time for today. Thank you so much for joining me.
No, thanks very much, Amelia, and look forward to working with you in the future.
And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic from Ezurio. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. You can't miss it, it's right across the top. Or head on over to YouTube, youtube.com/EE Journal.